Now, as per this problem statement, a first problem statement is we want to interface this peripheral to the microcontroller, PIC microcontroller, and when button 1 get pressed, that time we want relay and buzzer is on, whereas LED changing in one of the direction, that is left to right, whereas button 2 is pressed, that time relay and buzzer are off and LED changing in other direction. This is our problem statement. As per this problem statement, we construct the interfacing diagram. Here we are connecting the input device as a switch 1 and switch 2. Second device, that is LEDs, relay, and this is a relay and buzzer. In this fashion we interface all these devices to PIC microcontroller. We can use any port as per our choice. Now next, now as per to achieve this problem statement, we will just write the algorithm step. Now first step is that you must declare which port you are using, for interfacing peripheral to the PIC microcontroller. Okay, means you can declare B port, C port, A port, whatever you want you can declare. Whatever port you are using, just declare to the microcontroller. Means identify the port to which all these peripherals are attached. That is your first step. Now second step is when button 1 is pressed, that time you want to call one particular function. In that function you are turning on relay and buzzer along with LED changing in one of the direction, that is left to right. That is your next step. Third step is when customer press the next button, that is button 2, that time you are calling other function where relay and buzzer are off and LED changing in other direction, that is right to left. In this step we are just conclude the algorithm step as to achieve the problem statement. Okay, now first before writing the code, we will discuss there are in EPIC 18F4520 there are 5 ports: A port, B port, C port and D port, and along with E port. Whereas A having 6 bits or 6 pins, whereas B, C, D having 8 pins and E having only 3 pins. And in this fashion there are total 33 pins are available to interface the input output device or to interface the peripheral. GPIO, general purpose input output device, you can attach here. Okay, now next, now to support this PIC port structure, there are three registers are there. First register is called as a trias register, next one is a port register, then is a lat register. Now uh, first point is that all the ports, that is A, B, C, D, E, all ports are bidirectional port. Okay, now each port is supported by the 3 registers, and these 3 registers are in the architecture of 18F4520. First register is trias register. It is a 8-bit register because PIC microcontroller is also 8-bit register, and that's why trias register is also 8-bit register. Now is function of this register is to give the direction to the port. Okay, now each pin you can configure as an input pin or output pin as per your choice, and that's why trias register you are placing 0 when you want to declare that pin as an output pin, and you are just putting 1 to declare the pin as an input pin. In this fashion, by placing proper number into the trias register, you can configure each pin as per your choice. 1 means input and 0 means output. According to that, you can configure any pin as per your choice. Next one is a port register. Now port register, it is 8-bit register because controller is 8-bit register. Its function is to store the data received from the input port. For example, suppose you declared port as an input port. Okay, means you are connecting input device on the other end. Okay, when any data is coming from the input port, input device, you are accepting in the microcontroller. In which register? That is port register. Okay, whereas in the lat register is also 8-bit register, and it is supporting the transmission process. Means for example, suppose you are connecting a output device, for example LED, LCD, 7 segment display, Okay, that output device you are connecting to one of the port. That time you want to send something to the output device. Okay, and that data you are placing in somewhere, and that register is called as a lat register. Means lat register function is to store the data which you want to transmit to the output device. In this fashion, there are three registers which is supporting the port structure of 18F4520. Now next, now we will write the program to achieve the problem statement. Now in all, for all PIC practical, we are included this 5 statement in PIC practical. First one is that you are just including the PIC IC within the program, that is PIC 18F4520.h. Means this IC you are using, means in your syllabus this IC, particular IC is mentioned, and that's why we are using this IC in our practical, and that's why we are just including header file of PIC 18F4520. Then in 18F4520 there are different configure registers are there, such as a oscillator. Okay, there are various options are available for oscillator, such as a high speed oscillator, crystal oscillator, LC oscillator. Okay, RC oscillator. Number of oscillator options are available. Out of that, which option we are interested, you can choose here, that is oscillator. Okay, now here in our practical we are interested in a high speed oscillator. Okay, and that's why I'm just writing the set statement, and this is the syntax, that is hash pragma config oscillator is equal to hs. Okay, then next we config pwrt, that is power down timer. Okay, now this is off. Actually, this is one of the features available in PIC 18F, because this is providing facility to for more accuracy point of view. For example, suppose you initially your controller is in off condition. When you turn on the controller, immediately it will not move from 0 to 5 volt or 0 to 3.3 volt. It takes some time to move up to that point. Okay, means the settling time is there. Okay, up to settling time your controller must be reset for more accurate result point of view. Okay, means in some application accuracy is very important. In that case you are turning on pwrt, but just now we are just doing the normal practicals, and that's why we are not using pwrt function. PRW is providing the delay, settling time. Okay, for more accuracy point of view and for practical point of view we are not interested in that feature, because we want to save the power. Suppose you are turning on pwrt, it will take the power and you need more power, and power consumption is also one of the concept, and to save the power we are making pwrt off. Next one is a configure watchdog timer. Now watchdog timer is one of the feature to reset the controller. For example, there are two ways to reset the controller. One is the manual method, means directly press the reset button to reset the controller, and second method is automatically reset. Okay, means for example, suppose you are constructing the embedded system for a huge industrial panel. Okay, in that case, and that system is running 24 hours. Okay, anytime our system get hang, in that situation there are two way, either you turn on manually or automatically. Suppose you are placing manually, every time it is not possible to go to that particular location and reset the system. Okay, because our system run 24 hours. In that case we are referring automatically reset, means we are taking help of watchdog timer. Means for example, suppose our system get hang any time in between, in that case we will take the help of watchdog timer. With the help of watchdog timer we will place specific time there, for example 5 seconds. Suppose any time our system get hang, it will wait for 5 seconds, and within 5 seconds it come out of hang position, no problem. But till it remain hang position up to 5 seconds, it will automatically reset with the help of watchdog timer. But now we are making it off, because we are we are writing the program in laboratory, and in laboratory it is possible, easily possible to reset, press the reset button. Means manually we can reset the controller. suppose our system get hang, and that's why no need of automatically reset, and that's why watchdog timer is also off. Suppose you are using number of devices, that time it take more and more power, and it power consumption fails. And to avoid that, whatever features you are interested, you are just enabling that particular device, otherwise make it in sleeping mode. Similar way, debug facility is also off, and LVP, that is low voltage power, is also off. In this fashion, these are the five statement is common for all PIC microcontroller practical. Okay. Next point is, in your program you are calling the three sub function. One sub function is you are introducing the delay, then a write function. When particular switch get pressed, you are calling write function, and when second switch pressed, you are calling left function. Means in the main function you are not writing whole program in a main program, you are just writing in sub function, you are calling the sub function from the main. Okay. Then next point is declare the hardware connection. Now you are having number of input and output devices. One input device, that is a switch. Now output device is the LED, buzzer, relay, etc. Okay, you must declare where you are connecting in your interfacing diagram. Okay, now I'm interested in B port, and that's why I'm just defining with the help of this syntax, that is hash define switch 2. Okay, switch 2 is connected to port B. You can connect to port A also, port C also, port D also, port E also, as per your choice. Okay, but just declare where you are connected, and that's why I'm just writing the statement hash define switch to port B bits RB0. B port, okay, which pin, that is RB0, means switch 2 is connected to RB0. Then next, switch 1 is connected to RB1, and that's why syntax is hash define switch 1 port B. B ports which pin? RB1. Whereas relay is connected to hash define relay. Relay is the name of that device. Relay is connected to connected where? B port, which pin? RB3. Okay. Then four LEDs are there, and a buzzer is connected to output of relay. Yes. Now regarding next, that four LEDs you are connecting, the name of the LED is D1, D2, D3 and D4, and they are connected to B port, which pin number B4, B5, B6 and B7. In this fashion, which port you are using for hardware connection, you must declare here. Okay, with the help of hash define statement. Next one is your main program. In main program, void main. In main program, initially you are keeping ADS ADC on off position, because directly you are giving the digital data in form of zeros and one. Switch is one, switch is pressed or not pressed, means either it is 0 or 1. No need of ADC conversion, and that's why initially ADC is in off position. Then next, give the direction to the port pin. Here you are giving the direction with the help of trias register. Now trias B means direction for B port, which pin? B0. B0 pin we are connected switch 1, that's why it is a input device, and that's why we are writing here 1. Trias B bits, trias B1. B1 port we are connected switch 2, and which is input device, and that's why it's is equal to 1. 1 means input and 0 means output. Whereas B3 we are connected relay or buzzer, and which is output device, and that's why we are writing trias B bits. B ports, okay, which bit? B3 bit is 0, means it is in output direction. B4, B5, B6, B7. You are connecting LED1, LED2, LED3 and LED4. All these are your output device, and you are interested this pin must be in output direction, and that's why it is 0, 0, 0. In this fashion, you are just declaring the direction with the help of trias register. Now next, initially your all LEDs in off position. All LEDs are in off position, and that's why D1, D2, D3, D4 is equal to 0. Okay, and that's why LEDs remain in off position. When you want to turn on it, make it 1. Okay, then switch are initially it is 1. Okay, means you are not pressed that, means it is pull up to the VCC, and that's why it is 1. When you press one of the switch, it's become 0. Then regarding relay is also initially in off position, and that's why it is 0. Next, regarding while one main program, that is while one continuation loop. First, if switch 2 is pressed means it is 0. When switch 2 is pressed and switch 1 is open, in that case, which function you are calling? Relay 1 and write function. Whereas if switch 1 is pressed and switch 2 is open, in that case, which function you are interested? Relay off means buzzer off and left function. In this fashion, as per which button gets pressed, according to that respective function you are calling from the main function. Okay. Now first we will discuss the write function. In the write function, D1, D2, D3, D4 are initially 0 because initially all ladies in off position, while when you are pressing switch 2, that time switch 1 must be in off position. Okay, when you are pressing switch 2, your switch 1 must be off. Okay, means you are taking care both the switches are not in off press form. Okay, and that's why we are just checking switch 2 is pressed, and that's why we are just checking switch 1 is in open position or not, and that's why we are just checking switch 1 is not equal to 0. Once this condition is fulfilled, then you are making relay is equal to 1, means relay turn on, buzzer turn on. Then LED start chasing from one of the direction, that is left to right. Initially D1 is on, means first LED will on. It will on for 10 milliseconds. Then you turn on second LED by making D2 is equal to 1. You are just giving the delay, means for D2 will on for 10 milliseconds. After that you turning on the third LED, that is D3. It remain on for 10 milliseconds. Then D4 is on for 10 milliseconds. In this fashion, when switch 2 is pressed and switch 1 is open form, in that case relay is on and LED start chasing from left to right. Okay, means you are moving towards the right side, that is your right function. Okay, same way we are writing the left function also. When left function is called, that time initially all LEDs are in off position and switch 1 is pressed. Switch 1 pressed means you are just verify switch 2 is in release form or not. Okay, that's why switch 2 is not equal to 0, means you clear just take care that other device other switch is in open form or release form. In that, once this condition is satisfied, then relay is off, means buzzer is also off, and LED start chasing towards left side, means initially D4 is on. After 10 millisecond D3 is on. After 10 millisecond D1 is on, and after 10 millisecond D1 is on. In this fashion, LED start chasing from D4 to D1, means you are moving towards left side. Okay, and this is your left function. Now next is your last function is millisecond delay. In millisecond delay, you are calling the variable I time. I time is nothing but here 10. Instead of this, suppose I'm placing here 20, then it will call for 20 milliseconds. Suppose I'm placing here 50, it will call for 50 milliseconds. Okay, now I time is a 10 here. Okay, now within this function you are calling the two variable, one is I and second one is a G. Okay, now this I is moving from 0 to 10 because I time is 10 here. Suppose I placing 20 millisecond, it is coming 20. Suppose it is 50, it is coming 50, means I is varying from 0 to particular number. Okay, and J is moving from 0 to 1275. 1275 is the delay for millisecond because you want to generate millisecond time. Okay, and this is for millisecond, means 10 millisecond, 20 millisecond, 50 millisecond, like that. Okay, and this cover your cover the explanation of the code as per our problem statement.